What's up, Inspired Vision, plus anybody I might be catching on YouTube? This is day 10 of our Accelerated Algebra I course designed to prepare us for STAAR. So today we are translating system of linear equations and we're solving system of linear inequalities. So as always, it is time to learn some math. Let's tackle that STAAR test. Here's how today's going to work. We're going to do a warm-up question, then 4 guided practice questions, then 5 questions where I want you to try them on your own before you see me work them out, and then we're going to apply what we've learned to 3 STAAR released questions. So make sure you subscribe so you can get each one of these lessons to help us prepare. Okay, here's our warm-up question. We have 12x plus 15 minus 10x equals negative 25 minus 5y. Now also on the screen I have these shapes. These shapes I taught in previous videos, and these are our shapes to help us learn how to solve what step goes when. Now the first shape is an arrow. The arrow stands for the distributive property, and since we do not have parentheses in this problem, we don't need to distribute. The next shape stands for a fraction, and since we don't have fractions in this problem, we do not need to worry about clearing fractions, so we do not need to do this step. The next shape stands for circles, which we circle our like terms. We do have like terms in this problem. Our like terms in this problem is the 12x and the minus 10x. And if you notice, they're both on the same side of the equal sign. Our equal sign's right here, and they're both on the left-hand side of the equal sign. Which means when I combine them, I do not change their signs, I just add them together. So I am doing 12 plus negative 10, or just 12 minus 10, because plus negative means minus in math. So 12 minus 10 is 2x, and our x stays on the left-hand side, because they were both on the left-hand side to begin with. So now our problem is 12x plus 15 equals negative 25 minus 5y. And if you're staring at this problem wondering what to do next, our next thing we do is work down the list of the shapes, and we're ready for the rectangle and the triangle. Rectangle goes in front of y, since we're solving for y, and the coefficient in front of y is negative 5. So we put a rectangle around negative 5, and then a triangle in this problem goes on negative 25. Not the 2x, because 2x is on the left-hand side. Y is on the right-hand side this time, so anything else that was on the right-hand side needs a shape. We always get rid of the triangle first, so we're going to do plus 25, and we can only add it with the 15 because those are the only like terms on the right-hand side. So when we do plus 25, these cancel, and then 15 plus 25 is 40. So now we have 2x plus 40 equals negative 5y. One last step in this problem, and that is to divide the number in front of y. So we're going to divide everything by negative 5. And if we do 2 divided by negative 5, or 2x divided by negative 5, we get negative 0.4x. And then 40 divided by negative 5 is negative 8. But we would write it as minus 8 because it's the second term. Okay, so there's many different ways to write our equation right now. We have negative 0.4x minus 8 equals y if we keep the y on the right-hand side. But we like y on the left-hand side, so we can just switch it, no problem, because this isn't an inequality. Or if you prefer to write in fraction form, it would be negative 2/5 x minus 8. Okay, that's our warm-up, because we have to be good at solving for y today. Because today we are solving system of linear inequalities, like we see on the screen. So our first equation is x minus y is less than 3. Our second equation is y is greater than 4/9 x minus 4. So this works similar to our system of equalities, which is what we did on day 9. What we have to do here is make sure that they're both solved for y to begin with. So if you look, the first equation is not solved for y. So I'm going to use my rectangle and triangle, put 1's in front of both the y and the x, make my rectangle the negative 1 in front of y, and then triangle the 1x. Always move the triangle next, and that would be minus 1x on both sides. Remember that 3 minus 1x are not like terms, so I'm going to put them side by side like this. And then finally divide everything by negative 1. Now with inequalities, I want to ask myself, do I flip right before I do the division, right before I do the last step? And if you forgot why we flipped, here's the reasons. And we flip because there was a negative in my rectangle. Also, we would flip since we're solving for y, if y was on the right hand side, but y is on the left hand side, so we won't flip for this reason. But we do flip for the first reason because we're divided by a negative number. So 3 divided by negative 1 becomes negative 3, and negative 1x divided by negative 1 becomes positive 1x. Now, since we have a system, our next step is to put both of our equations into y equals. So both of these equations go into y equals, and then I graph. Now, if I can see where they cross, then all I need to do now is, we're not worrying about where they intersect like with normal systems, but what I need to do now is know what these symbols mean, and both of these symbols mean that I need to shade above. So both of these symbols that I'm talking about, both my solved equations, mean I need to shade above. So you can think about this like in your head, or I could show you how to do this in your calculator later. But you need to think that both of these lines, so here's the first line, and here's the second line, both of them need to be shaded above. So when you're looking for your answer choice, you're looking for where they're both shaded in, which would be answer choice D in this case. Okay, hopefully that makes sense. We're going to do another one before you start your own questions. The other thing that we're doing today is translating word problems into just systems, or just writing them for right now. So the first sentence of number 2 says the sum of two numbers is -7. So since we're talking about systems here, we're going to use two different variables to represent two numbers. So the sum of two numbers would mean x plus y. And is means equals in math, and that would be equals -7. The second sentence says the greater number, but we don't know which one of these are greater since we're just adding. So that could mean x in this case, or y in this case. But either way, the greater number minus the lesser number, so that could mean x minus y or y minus x, is 3. Now they ask us which system of linear equations can be used to find the two numbers. So they're not asking us to solve, they're just asking us to write it. So in this case, the one that matches up is B. Okay? So if they wrote y minus x equals 3, that would also be correct because we don't know which one's greater. Number 3. This time it's a little different. It says the difference of two numbers is 10. So the way that it could start this off is x minus y equals 10. Then it says the greater number. In this case, if I put x first and then I subtract y, then x has to be the bigger number, the greater number. But if you started this off separate, then y would have to be the greater number. But if you just have what I have, then x has to be the greater number. And if you read the second sentence, it says the greater number is, so that means x equals 3 times the lesser number. So this is my second equation. So tricky wording. But we would match that up to be, we would match that up to be A in this case. Okay, now, next, this is our last guided practice question. We have two equations of linear inequalities. We have x plus 4y is greater than -4, and we have 3x plus 2y is less than 6. When we're solving systems, we have to make sure they're solved for y. So I would take both equations. With my first equation, I would want to put 1 in front of x, then set up my rectangle to be the number in front of y, which is plus 4, triangle be to 1x. Subtract the triangle on both sides. Notice that's -4 minus 1x, so I would put those side by side, and then divide both of them by +4. Before I do this division, I have to ask myself, do I flip? And because y is on the left-hand side and I'm solving for y, and there's no negative that I'm dividing by, I do not flip. So it stays -1 minus 1.5x after I finish dividing. So that's my first equation to solve. Second equation, I would set up my rectangle triangle, subtract 3x on both sides, then divide them both by positive 2. Ask myself, do I flip? No, I do not. No negative in the rectangle. Y is on the left. So 6 divided by 2 is 3. Negative 3 divided by 2 is 1.5. Bring down my x. Okay, now I need to put both of these into my y equals key and graph it. Now when you graph it, pay attention to which one comes out first. If you type this one in first, then that would be this line. And you have to use this symbol, which means shaded above. So since I wrote this in red just to help you visualize this, I shaded it in red above the line. And this one in blue, that's a less than symbol, so that would be this line shaded below. We're looking for the double line. Now, if you have a problem with shading, I actually cover this in one of our independent practice questions. But hopefully you can see this without using your calculator, because it'll be a little bit easier if you can see it without using your calculator. But if I was to match up these answer choices, this would match up to answer choice A. Okay, so you're going to do 5 questions. Hopefully you can do these on your own. So write these, and then we'll cover the answers here in a minute. So here's the first question. Second and third question. Fourth question. And fifth question. Try these on your own. I'm switching the screen in 5 seconds. Okay, number 1, we have a system. So the first thing I should notice is the first equation is already solved for. The second equation is not solved for. So I would want to move over my 2x by subtracting, divide by -5, and because I'm dividing by a negative number, we do flip the symbol to be greater than. Then I would type them both into my y equals key, and then look at the graph. Since the first one is less than, actually it's going to come out to be the second one, but the second one is less than, which is this line, I would want to shade below this line. And then now that it flips to greater than on the other line, it would be above this line. So if you can't visualize that in your head, then this is what you can do. You can go back to your y equals key. Since this is greater than, you need to have the up arrow. Now in a TI-84, it's done a little bit differently, but it's still, you're using the up arrow for greater than, and then for less than, you would shade below. And if this helps, your calculator screen should look something like this. If you're using an 84, it will be in color, depending on your calculator. But you're looking for the double shaded up line. And in this case, your answer is A. Okay, number 2. Number 2 talks about the sum of two numbers is 40. So we're using x plus y to equal 40. We don't know which one's the greater number, but most likely they're going to pick x to be the greater number. And then x is 9 times the lesser number, so that answer would be C. Number 3, we have the sum of two numbers is 1. The lesser number, so this could mean x minus y, is the lesser number minus the greater number is -3. So whichever one's less, that one comes first, minus the greater number. And the way that this is written, the lesser number in this case would be x. So kind of tricky, but that's why I wrote it twice out first before looking at my answer choices. All right, number 4. I need to solve both of these for y. And when I solve them both for y, they actually both will flip. The first equation flips when I divide by -1. The second equation flips when I divide by -8. And I chose to write it in decimal form here. You can keep it as a fraction if you like, 3/8 x. After you finish solving them both, you put them in y equals. And then notice that both of these are greater than symbols now. So this one would be shaded above, and this one would be shaded above. And if you can't visualize that, then you need to go to your y equals key and then change your arrows to both mean up. Now, the bad thing about using arrows is you have to fix this after every question that you do, or you need to reset your memory by doing second plus 7, 1, 2. Okay, after you change both to be up arrows, it would look like that. So your answer choice would be B. All right, last question. Hopefully you got this one right. So first thing you notice is that you need to solve them both for y. So I'm going to use rectangle triangle to move over my 3x, divide by 2, and I do not flip. So it stays as less than or equal to. On the second question, move over my 1x, divide by 4, and it does not flip. So it stays greater than or equal to -1 minus 0.25x. Put that both in my y equals key. Look at the graph. Now this time when I graphed it, my first line coming out is this one, and that would be shaded below. My second line coming out is this one, and that would be shaded above. Now if you can't visualize where they cross, then change the first equation to be a down arrow and the second equation to be an up arrow, and then they double cross right here. So that answer would be B. Okay, so what we're going to do next is going to do 3-star questions and apply this to the 3-star questions. So here is question number 24. Or sorry, question out of the STAAR Test 2015. So the first sentence says, a new spiral notebook contains 30 more sheets of notebook paper than a new memo book. So they're talking about two different variables in that first sentence. They're talking about a spiral notebook, which they are going to say is S, but I like to say it as X to begin with, has 30 more sheets of paper. So to write this as an equation, this can be tricky. You could write it as X is 30 more than Y, or M equals, or sorry, that would be S. S equals 30 more than M. Or S is 30 plus M if you would to change the variables. Or if you were to bring both the variables on the same side of the equation, then it would be S minus 30, or S minus M equals 30. So 3 different ways to write this equation. These two are just using S and M, and this one's when you have both variables on the same side of the equation. Hopefully you can see this because this is the key to the question. Now the second sentence is pretty easy. It says the total number of sheets of paper and 3 spiral notebooks, so that's going to be 3 S and then 5 M, and then is means equals in math is 810. So there's the second equation. Now we do not need to solve these equations, so my answer is just F here. If I were to solve both of them, that's the reason why I like to use X and Y, because we would want to solve both of these equations for Y, but we don't have to do this in this question, so let's just move forward. Another STAAR question. This one's talking about a wall inside of a shoe store is used to display walking shoes and running shoes. So there's 2 variables right here, either X and Y, or call this W and R. Now it says in the second sentence there's 135 pairs of shoes in this display. So the first 2 sentences go together. So that means we're going to have X plus Y equals 135. Now the third sentence says there's 1.5 times as many walking shoes as running shoes. Now if walking shoes is X, that means 1.5 times as many of those shoes as running shoes. So that means 1.5 times X is your Y. Now, it wants to know how many pairs of walking shoes are on display, walking shoes and running shoes. The only way to do this is to solve both of these equations for Y. The second equation in purple is already solved for. It's just Y is on the wrong side, but that's no problem. We can switch it. It's this one, the top one, that's not solved for. So if I set up my rectangle and triangle, move over 1x, then I would have y equals 135 minus 1x. Once you have both equations solved for, put them into your y equals key, and then look at the graph. If you notice that the graph you only see one line, so not 2 lines. So since I don't see 2 lines, I can't use my trick that I learned on day 9, which is look at the intercept. So I'm going to look at the table to figure out when my y1, y2's match, which is right here at x is 54, and so that would mean my walking shoes is 54 and my running shoes is 81. So that would be G in this case. Okay, last question for today. So we have 56 laptops and desktop computers in a lab. These are my 2 variables, and there's 156 of them, so I can set that equal to 156. Then it says there's 8 more laptops than desktops. So if laptops is my X, there's supposed to be 8 more in order to be equal to Y. So I would have to put the 8 over here for Y. That way they're equal to each other. So if they're wanting to know a solution, which they are in this last sentence, I have to solve both of these equations for Y. So my first equation, I would move over my 1x and then say y is 156 minus 1x. My second equation, it's almost solved for y. I just need to move over the 8. So then y is x minus 8. Once they're both solved for, put them in your y equals key. Look at the graph. You can't find where they intercept. So we have, if I use my table, they are going to get closer and closer together as I scroll down. So if you keep scrolling down, you'll finally see where they meet up at 82. And since they want laptops, and we said laptops was my X, we would want to pick my X in this problem. Okay, so that's our lesson for today. Hopefully you got something out of it, and stay tuned for the next lessons to help us prepare.